All right, here we are with the practice exam for Algebra 1B repeat. Okay, I'm going to go through this whole thing, and if you do anything else, hopefully you at least watch this video. Okay, anything to the 0 power is 1. A negative power flips it, so if we think of it like this, it just gets flipped to the bottom to make it positive, so I get 1 over x to the 3rd power as my answer. Again, that negative became positive in the bottom. When you have the same base, you can just add those exponents. It's 4 to the 9th power, and the directions say to just leave it like that. I don't need to put that in a calculator. When you see a parentheses, that means you times these and you get x to the 12th power. And when it is divide and with the same base, you subtract the exponents and you get a squared. Okay. For the next problem, again, this little 2 means you got to kind of distribute it through here, kind of like what we did here. You multiply. So it's 2 to the 1st power times 2 is 2 squared, x squared, y squared, times 2y over x. And I could put it all together. 2 squared is 4 times that 2 gives me 8, x squared y over y squared x. Because when you times, you just times the bottoms and the tops together like that. Then I can start simplifying. I could take a y out of here. This y2 looks like that. So I can take a y out of there and a y out of there. I can do the same with the x. This is x, so I could take one of those and one of those. So by the way, I already rewrote these. So here it looks like I've got 8 and x left on top. I've got just a y left on bottom, and there's my answer. Similarly, again, this gets distributed, and 3 to the 2 times 2 is 4, a to the 3 times 2 is 6, and b to the, again, 1 times 2, which is 2. And here, it does ask me to actually simplify. 2 to the 5th means 32. So 3 to the 4th power means 3 times 3 times 3 times 3, which, by the way, is just 9 times 9, which is 81. And then I'm just going to bring the other ones along for the ride. Okay. There's that. Let's keep going here. So on the next part, you're just going to plug it in. And if you don't remember what I mean this. So for 3 to the x power, and to plug in all those numbers, I would go, oh, of course I grab a calculator that's dying. Let's try a new one. Okay. All right, so I go 3 to the power of negative 2. And I get 0.1 repeating. Okay, so I write 0.1 repeating in there. Okay, if you just wrote 0.1, I'd be okay with that. And then I go 3 to the negative 1 power, and I get 0.3 repeating. And I go 3, I don't have to do 3 to the 0 power. 3 to the 0 power I know is 1, because anything to the 0 power. 3 to the 1st power is 3, of course. And 3 to the 2nd power is 9. So I go to graph these. It should be one of those, phew, because it's exponential. And sure enough, you know, that's pretty close to the axis. It never crosses that. Right about there. 1, 3, 9. Connect my dots. Okay. And I'm just going to go do the same thing here, and then we'll answer these questions down below. So for this, I would literally type it in as I see it. I'm going to go 3 parentheses 1 divided by 2 parentheses to the negative 2 power. And it gives me 12. Okay, so 12 is in there. Okay. 3 parentheses 1 divided by 2 to the negative 1st power. And it gives me 6. Okay, so 6. I'm going to keep going. I'm just going to press second enter. If I press second enter, it comes up again. Then I can just delete this and write 0. Now again, notice this is 3 because it's going 3 times a half to the 0. So it's taking half to the 0, which makes that 1, times 3 is why it's 3. Okay, second enter, go replace 0 with 1. I get 1.5. Second enter, go replace 1 with 2. And I get 0.75. Okay, then I'm going to go graph these. Well, negative 212 is kind of off the graph a little bit up here, but the rest of these, I can get that in there. And there we go. There's the graph. Okay. All right. So the domain and range for these things. The domain is all the same thing. The domain means this way, x values. And this is going to keep going that way, and even though it's going up, it's going to keep going that way. Same thing here. It's going to keep going that way. It's going to keep going that way. So the domain for both of these is all real numbers. Okay, you can write that in, or you can just do that. The range is always above the axis. The x-axis here is never going to touch it, so that means y is greater than 0, because this is 0, and it's never going to be quite 0. And it's the same over here. They're the same thing. And then the y-intercept is going to just depend on the problem. If I look here, it's 1. So 0, 1. Over here, 0.3. Okay. All right, so let's move on here. Down at the bottom, it's talking about growth or decay. Growth or decay is based on this number right here. If it's greater than 1, it's growth. It's that simple. If it's less than 1, it's decay. This is worth like 3 points, half for each box on the exam. Just literally remember that if it's less than, it's decay. If it's greater than, it's growth. This first number out here, first is initial. So that's 225, and that's 75. That's pretty easy too. Now the percent rate of change might get you a little bit. This is its growth factor. This is not a percent, this is a decimal. To change a decimal to a percent, we move the decimal over 2 places, and it's 115%. To change this, we would move the decimal over 2 places, and it's 90%. Okay, that's how we do rate of change. Percent rate of change, excuse me. So again, that would be out of like 0.5 for each of those. Let's go to the next page. About 6 minutes in, I'm going to make 2 of these videos, one for the first 3 pages, one for the second 3 pages. All right, so the next part, again, we're using this equation up here, and this is our initial value, and this is our increase or decrease. So our initial, so we got y equals the initial value, 28,000. In fact, I'm going to do the next one at the same time, 5,000, because it's telling us that value. Then in parentheses, I'm going to put what I'm going to do next. If I decrease by 16%, that means I'm going to go 100% minus 16% because I'm decreasing, I'm going down. That's 84%. And again, to change that to a decimal, I move it over 2 places to make it 0.84. When it increases, I add it to 100%. And I get 108.5%. And again, to change that to a decimal, I go over 2 places, 1.085. Okay? And then it's to the t power, which means the year. So here it's 10, and here it's 9. And then I'm just going to go plug it in. I'm going to plug it in exactly how I see it. 28,000 times 0.84 to the power of 10. And I'm going to round this to the nearest tenth, which means I'm going to look at that 4. That's under 5, so that's just 23. So 4, 8, 9, 7, and 23 cents. With a dollar sign, this is a story problem. It needs a label. Okay. Next problem, let's see, I'm going to plug it in here. 5,000, 1.085, which is a big return, by the way. Yeah, because that's a lot of money. $10,419.28. Again, if I look here, I see that 8 in the third spot. That rounds that up to the next decimal. That's how I get 28. Okay. All right. Next few problems are just simplifying these things and really combining like terms. So I've got a 2x cubed and a negative 2x cubed. They cancel each other out. I can combine those. That's a negative 5 minus 1. That's negative 6x. The name then, monomial means 1, so that's monomial. Binomial, trinomial, polynomial. Actually, it's technically 4 or more. The leading coefficient here is just the number in front, and the degree is whatever exponent is here. When there's nothing there, it doesn't mean 0. It means 1. Because the 0, it would go away, it'd be 1. So it's to the first degree. Can't do anything to that. And again, when I'm writing this in standard form, I need to have the highest exponent first, and then the next, and then the next. I can combine those to get a plus 7x. It is a binomial because it's 2. Leading coefficient is that number in front. Okay? And the degree is the exponent of the highest degree. There it is. Okay, I've got an x to the 4th here. I've got, let's see, so I'm going to get that out of there. I've got a 1x minus a 5x. That's a negative 4x. And I got a plus 2 and a plus 3 to give me a plus 5. That's trinomial because it's 3 terms. Leading coefficient, when there's nothing there, again, it's not 0, it's 1. And the degree here is 4. Okay? Kind of continues with what we're doing on this. For this one, for plus, everything gets written out as you see it. Okay, and then you would just combine like terms. So I've got 5x squared minus 7x squared, that's a negative 2x squared. A negative 3x and a positive 3x, they'll cancel each other out. And a negative 2 and a negative 2 to give me a minus 4. Okay? When it's minus, though, you've got to treat this like a negative 1, and it gets distributed. So it changes the sign of everything past it. So nothing here changes, but everything over here changes. And I would suggest you write it out first, because people try and do that in their head and they make mistakes. Those two give me a 1x squared. A 5x minus a 2x gives me a positive 3x. And a negative 3 and a positive 4 gives me a positive 1. And there's my answer for that. Okay? Distribute, if you remember, I get 2x squared because of x times x, and then minus 8x. Distribute here, 5 times 3 is 15. Again, y squared because there's two of them. And 5 times 2 gives you 10y. Okay? All right, let's keep going here. Down at the bottom, we're going to use the box method. It says it right in the directions. It will on the exam as well. So, box it out, okay? Write your one term there, your other term there, and multiply. X times x gives me x squared. X times negative 3 gives me negative 3x. X times 3 gives me 3x. And 3 times negative 3 is how I get that negative 9, again, because I'm multiplying those, and so on, okay? Then I see I need to combine my like terms here. So I get x squared. A negative 3 and a positive 3 will cancel each other out, actually 0. So minus 9 is my answer. Okay, I'm going to keep going here with 4x plus 1, 2x plus 3. And again, 2 times 4 is 8, and there's 2x's, so x squared. 1 times 2x, of course, is 2x. 4x times 3 gives you 12x there. And 3 times 1 is 3. Again, the lead term goes up front. I combine terms here to get a plus 14x, and then plus 3 on the end. Okay. There's page 2. Let's go on to page 3, the last one for this video. All right, so number 10. We're going to use the X box for these. So I'm going to start putting this out here. Okay, and to get, actually, the things that I know for sure is that first term goes there, so I'm going to put that in both of them. I know the last term goes there, so I'm going to put that in both of them. I know the middle term goes there, and that is always, 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 always going to be the case. Hold on a second. Now after that, to get this number here, we times those two things together, and I get 15. To get this number there, I times those two together, and I get negative 18, because that's just a 1. Okay? And then you can use a factor sheet here. You find the numbers that will multiply to give me 18 and add to give me negative 3. And 3 times 6 is 18. To give me a negative 3, I need a 3 minus a 6. That will give me a negative 3 if I subtract 6 from 3. If I times those, I get negative 18. Those get x's on the inside, and we just GCF from there. The thing I could pull out of both of those is a 3. I can pull an x out of both of those. I could pull an x out of both of those. And out of both of those, I can pull a negative 6 because that first term is negative. It gives me a negative. And there it is, x plus 3 and x minus 6 from here and from here. Then I set both those factors equal to 0. So x plus 3 equals 0 and x minus 6 equals 0. And on this one, I minus 3 to both sides to get negative 3. And in this one, of course, I would add 6 to both sides to get x equals 6. Okay? Same kind of thing over here. Numbers that multiply to give me 15 and add to give me 16. Well, that's pretty easy. That's just 15 and 1. So I'm going to put 15x here and 1x here, and I'm going to GCF out of here to get a 5. GCF out of here to get a 3 and an x. Out of here to get just an x because of that 1. And out of here just a 1 because, again, of that 1. So there it is, x plus 5 and 3x plus 1. I can kind of check myself here. When I times these, I get 15 plus 1. That gives me 16. 3 minus 6 gives me the negative 3. I can kind of check that. Again, setting these factors equal to 0, this one is pretty easy because I would just go right into one step. But the other one, I feel like people aren't going to remember. We minus 1 to both sides first. Those cancel. I still have 3x. So I need to divide to get x equals negative 1/3 as my other answer there. Okay. All right, on to 11 and 12. So on 11, again, we're going to use the calculator and just plug that in. This happens a lot on this thing. So 3 parentheses, because I'm plugging it in, negative 2 parentheses squared minus 8. And I get 4. 3 parentheses negative 1 to the second power minus 8. I get negative 5. When I plug in 0, 0 goes away, it's just minus 8, it's negative 8. Okay, and then I'm going to second enter here so I can go back and change this to a 1. So I'm going to just delete that little negative sign there and press equals, I get negative 5. Oh yeah, these things repeat, so I bet that's 4. All right, 0, negative 8 is my vertex because it's always the center one. Plus, if I start to go graphing this, watch what happens. Negative 2, 4. Right there, negative 1, negative 5 is down here. 0, negative 8 is down here. 1, negative 5 is here, and 2. You can see it yourself. You don't have to fill in that vertex right away. You can graph it and then be like, oh yeah, there's the vertex right in the middle. So similarly here, again, I'm going to go negative, parentheses, negative 2 squared. I can use that little squared button instead. Minus, or excuse me, plus 6. And I get 2. I know from 0 I'm going to get 6. I'm going to plug in negative 1, so second enter gets it to come up again. Just going to put in 1, and I get 5. And then I remember that they just repeat over there. My vertex is, again, that middle point. I'm not trying to fool you with that. Go graph it, you would see negative 2, 2, negative 1, 5, 0, 6, 1, 5, 2, 2, and there it is. All right, so this is as far as I'd like you to get on the first day of the review. So I am going to cut this tape, and there will be a second tape for the rest of this.